3.5, symmetry. So we have two types of symmetry. Our first is reflection symmetry. So reflection symmetry is a type of symmetry where it is reflecting and mapping onto itself. Rotational symmetry is a symmetry where we are rotating the image a rotation of less than 360 degrees. Okay, example 1. What transformations can be used to map the figure onto itself? Why can some of the figures be mapped onto themselves? Okay. So our first image here. Okay, so first we're going to look at reflection. Okay, so reflectional symmetry, we're reflecting it over a line. So okay, so for this one, if I was to create a line of symmetry, I could either create a line of symmetry here, we'll call it in, or a line of symmetry going down this way, I'll call it M. Okay, so that's two ways that I can have symmetry in that image through reflection. We can also have rotational symmetry. Okay, and we do that by rotating it around a point. Okay, so if I create a point here, I would be rotating this around that point by 180 degrees. So my rotation then would be 180 degrees around point P. Okay, let's look at our try it. What transformations map the figure onto itself? All right, let's look at a reflection. Okay, so we could reflect this through a vertical line through the center. Okay, we could also reflect it over a horizontal line. And then for a rotation, we could rotate it 180 degrees. Okay, B. So the only transformation I can do here is a reflection. I wouldn't be able to rotate it because if I rotated it, I would have to rotate it fully 360 degrees, and that defeats the purpose. So we can only do it through a reflection, and that's through a vertical line straight through the center. Okay, example 2, how many lines of symmetry does a regular hexagon have? Okay, so we're gonna kind of sketch these out to identify them. So I've got 1. I have 2, 3, but I also could reflect it down the center like these. So 4, 5, 6. So I have 6 total lines on this one. Okay. How many lines of symmetry does the figure have? And how do we know when we've found them all? Okay, so this rectangle, I have a line of symmetry horizontally and vertically, so there's only 2 lines. I can't have a diagonal line because if I reflect that, it's going to reflect down this direction. Yeah, that's not even going to work. Okay, so I can't reflect it diagonally. All right, B, I only have 1 line of reflection, and it is directly down the center. Okay, again, I can't reflect it diagonally because it's not going to give me the same image. As we can see, this angle is a lot larger than this angle. I'm not going to get that same image. Likewise, I cannot reflect it across a horizontal line because the top is a lot smaller than the bottom. Okay, next we're looking at point of symmetry. Okay, so a point of symmetry is a symmetry in which an image maps onto the pre-image after a rotation of exactly 180 degrees. Okay, so we're looking at all of our angles of rotation. So we have an equilateral triangle. To map an equilateral triangle onto itself, we have 3 rotations that it could make. So we would be taking 360 degrees, so the total amount that it could rotate, and we're dividing it by 3 because I can rotate it 3 times and it will perfectly map on itself. So each rotation would be 120 degrees. So we could rotate 120 degrees or 240 degrees to get the figure to map onto itself. A parallelogram. So in order to get a parallelogram to map, this one has a point of symmetry, and we can rotate it exactly 180 degrees. Okay, next we want to find the rotational symmetry for these images. And is it point symmetry? Okay, so if I find how many lines of symmetry there are, I have 2 lines of symmetry. And then I have another 2 lines of symmetry. So I have 4 total lines of symmetry. I'm going to take the 360 degrees, divide it by 4. That would give me 90 degrees for each rotation. So I could rotate to 90 degrees, 180 degrees, or 270 degrees to get it to map onto itself. Okay, next. Okay, I have 2 lines of symmetry here. So to find my rotational symmetry, I take 360, divide it by 2. So I would get 180 degree rotational symmetry. So this is point symmetry. right, what type of symmetry does the figure have? Okay, so we're going to find our lines of symmetry here. Okay, so I have 5 lines of symmetry. So 1, 2, 3, 4, 5 total lines of symmetry. So I take 360 divided by those 5 lines, and I would get 72 degree. So then all of my degrees of rotation could be 72 degrees, 144 degrees, 216 degrees, and then 288 degrees. Okay, so this one, in order to get this point to go all the way over here, I have 180 degree symmetry or point symmetry. Okay, so next it's asking us what is the symmetry of a square. So let's sketch out a square. Then we want to find our lines of symmetry. So I have 1, 2, 3, 4 lines of symmetry. Okay, so if I take 360 divided by 4, that gets me 90 degrees. So 90 degrees, 180 degrees, and 270 degrees. So it has rotational, and it has point of symmetry. Okay, a company CEO wants a new logo that looks the same for each rotation of 30 degrees and uses the 3 company colors. What are some possible logo designs? Okay. I'm not going to fully do this one with you, but I'll give you the basis so you can get it started. So you're creating 30 degree rotations. Okay, so we're going to need 6 lines of symmetry. Okay, so let me go ahead and add some lines in here. Okay, so not the best sketch, but you get the idea. You'd use a ruler and make it a little bit more accurate. So you would create a logo that are using those 6 lines of symmetry to create a logo that when you rotate it, it gives you the exact same image. Okay. I cannot get this to stay. Okay, so the try it, you're doing the same thing, but you're using 60 degree rotations instead. So that would mean you need 3 lines of symmetry.